Hello, my name is Zirko, and in this video we'll be going over how to 3D scan your car for free. We'll be using a free program called Meshroom that uses Photogrammetry. It uses a set amount of photos to calculate a 3D object in space, as opposed to LiDAR, which uses lasers to recreate a 3D object. For photogrammetry, all you need is a camera and a PC or laptop with NVIDIA graphics. The photogrammetry process is fairly simple. Like any photogrammetry tutorial, you need a set of 360 photos of your object, keeping at least 60% of the object details in frame from the previous shot. But we run into problems with photogrammetry in cars, as traditionally photogrammetry requires your object to be matte or rough in surface texture, along with plenty of unique details along the surface for the program to calculate and reconstruct the object. With the nature of cars being large, shiny objects, the program has a tough time recreating the object in 3D space. It also means we have little control over these parameters, but there are some techniques we can use to help improve the result. For lighting, we can shoot photos on an overcast day, or in a shade in this example, or even in a parking garage. But take note, there will be a lot of light reflections in the paintwork due to the number of overhead lights you'll be shooting in the photo. You can also use a polarized filter if you can afford one, and it will greatly help cut down the reflections in the paint. As with the smooth surface of the car, try taking a set of photos when it's dirty. The dirt greatly helps the program help determine the surface shape of the vehicle. But if the car is clean and it's your personal car, or you have permission of someone else's car, can buy a roll of painter's tape and put markers around the car. Try to make each mark a bit unique, as the program can sometimes get confused, and sometimes we'll take two separate different markers and mark it as the same one. So in this instance, I would put markers all around parts of the car where there's a lot of reflections, usually on the topmost surfaces, putting X's or marks, as the marks will help determine each unique part of the vehicle. Putting markers in such a way will help determine the surface of the object and help align the cameras in the program. With that in mind, we won't get a perfect model, but we will get a usable model. As here is one of my best case scenarios with my personal car. It looks fairly accurate. All of it's there. You can tell the areas where there wasn't enough information to generate from, like the windows or the roof. When you get up close, it starts to fall apart a little bit, but you can always go back and do another set of photos of specific parts to get a more accurate 3D render. Now, if I take the texture off, you can see the underlying mesh. You can see there's still quite a bit of detail. You can see where the highlights and reflections messed up the 3D scan, as basically a lot of craters and holes along the edges where most of the reflections bounce off into the camera. You can see the grille, see the hood scoop. You can even make out the door lines, the door depth and shape, the wheels, and so on. Generally, you want to do a baseline model where you can work off from, and then you can start adding more like detailed scans, as I will show you in a second here. So here I'm going to hide the main model and show you the detailed model I've done. And here I've focused mainly on the garnish here. You can see it's produced a lot of good detail. You can see the 4Runner emblem, even the Toyota Taurus, even though it's all chrome and some of the detail lost. You can see the window trim, see the panel lines, even the power buttons for the window. So here we are in Meshroom. The first thing we're going to do is save it as a demo. Meshroom will not technically render until you've saved the project. So first thing we're going to do, I'm going to grab about 8 images and drag them and drop them to their images side panel here. And we're going to go structure for motion and compute. Basically what it's doing is just basically finding all the details of your photos, matching it up with other photos, and recreating an object from it. Usually the photos you want to have will be at least 4K in size, plenty of detail, sharp, non-blurry photos, and so on. The more detail, the better Meshroom will sort out the details and recreate the object. So here we can already see it's recreated the side of the vehicle from our photo set with 8 images. Usually what you want to do is make sure all these photos and details are aligned. If you see in the viewport, each of these little boxes is a camera recreated in 3D space. You can actually tell where I stood in that parking lot taking that photo. So to check that all the data is in the right angle, you're gonna go over the top here, click on the camera, and click on the photo on the left-hand side. As you click through them, you can see the camera and the viewport changing and matching to the image. Sometimes the overlay will be there, sometimes it doesn't work, like right now. It's just the nature of this program. It's a free program, there's bugs in it. But yeah. So now that we know and verify that all these images are aligned properly, you can click off that, click off the camera and go back to your 3D view and add another set of photos. What you want to do is drag and drop to the images and go to augment reconstruction. That will create a new node set underneath our current set. And we go to the next structure of motion, and we'll just want to compute that. And that will add the new set of photos and data into the main one. So our new data is rendered in. We now have a new set of cameras. We got curiously all these overlapping cameras. That's just the cameras from the previous calculation being shown at the same time. So here in the scene, we have our first calculation and our next calculation. We don't need to see the first calculation. So now we just see the cameras in our current calculation here. And you can check by turning on and off, see how much more new data has been presented in our current point cloud here. Again, we're gonna click on the camera, make sure everything's aligned properly, because sometimes this image will be flipped 180 because it's referencing the wheel and thinking the front wheel is the same as the back wheel, and the whole program will offset that information by one whole wheel in that case. So everything looks good. I'm gonna put another data set in. So one thing to note that you can play with is display features. It basically shows the program scanning all the unique parts of your image and relating them back to each previous image. From what I've gathered, the orange parts are unique parts in the images it's defined. Blue is mostly garbage data. And the red dots are the ones that have common points with previous images in your set. Again, we'll make sure everything's all nice and aligned. Nothing's funny's happened here. And we'll finish off putting the rest of the data set in and go from there. Also be aware that don't play around with this too much, as I find that it can crash the program. The reason why I'm using 8 to 10 photos per data set is because most tutorials will tell you to just dump the whole data set in. I find it's really slow, it's cumbersome, and you will often get errors doing photogrammetry with shiny objects like cars by doing it that way. Doing with small sets allows you to have more control, make sure everything's going right. If anything goes wrong, you can catch it early before wasting hours just having it render, and it'll keep you out of trouble. So here we're going to look through one last time. Most of it's okay. Up until you hit this one, you can see the program has completely flipped the image 180. It's probably, again, reference to wheels as the main detail point, but the whole image is the wrong way around. We don't want that, as that will skew the data when we render out a mesh. So what we can do is just delete the image from the set and re-render it, or we can troubleshoot it by first going to feature matching and turning on guide matching. If that doesn't work, what we'll go is down to the next one down from vocabulary tree, go to sequential vocabulary tree, which basically is saying we're using a video sequence, trying to help sort out that alignment. And the very last one, which is most time consuming, is turning the describer density from normal to high to ultra. Do take care in mind that taking these describer qualities up higher will ultimately slow down the point generation process. But for now, since we got plenty of data, we're just going to leave that alone and just delete that one image. Let's go back to normal. And we'll just delete that one image and render it again. So here we are again. And it screwed up again. That's not good. Let's keep this tutorial short. We're just going to ignore that. Another thing to note is these the little aperture and shutter here. The aperture means it's found the correct info for your camera. It will show you that the program has successfully recreated your camera in 3D space. This will greatly help in the reconstruction of your object. If it's red, it means it hasn't found any data on your camera. With the little camera here, it just means it's successfully reconstructed the point data. If it's red, it hasn't. So ignoring this misaligned image, we're going to next go to meshing, and we will want to create a custom bounding box. The bounding box will only recreate the mesh within the box. So we're just going to move the box within. I'm just going to move the box over the car, as we don't want to render the rest of the parking lot here. Don't have to get too crazy, just so it's within the box, and that should be good to go. You can turn off the box so you don't actually adjust it by hitting the little crop icon. Next, well, this is going to go all the way to texturing and compute. Depending how fast your GPU and computer is, it'll take like a minute to an hour, depending how dense your point cloud is. And you can tell how much you have in your point cloud is in the scene bar here, and it will show you how many points there are. In this case, it's just under 50,000 using 46 cameras. Okay, it's been about a half hour now. It's finally done rendering. As you can see, it's done a fairly alright job for the data set I gave it. It's about 1/4 the amount of data I gave on my demo model, but anyway. So now we're going to double click on texturing and give it a second. Texturing will pop up. Now make sure we're on our texture view, and we're going to turn off meshing. Now we can see our texture model. As you can see again, it's mostly there, despite all the holes on the top leading edge of the bodywork. But it's good enough for what we want to use this for. So now what we want to do is take the model we generated and export it to Maya or Blender. So what you want to do is go down to Mesh and open containing folder. I know you can't see it on your screen, but on my screen it'll open up a new Windows Explorer folder with your OBJ inside it. Now we're going to go back into Maya and just drag and drop that OBJ file into the scene. In this case, I'm just going to drag and drop my completed model from my previous session. So what I'm going to first do is scale your model up. What you can do is modify and center pivot to make life a bit easier. We're gonna turn our texture on. Let that load up. Turn it on for each viewport. Now we're going to orientate our model, as Meshroom just gives you arbitrary values, and as you see, it was upside down a second ago. What you can do to reference your orientation is use the body lines of the vehicle, such as the door lines, hood lines, anything that can be referenced on both sides to straighten out the model. Okay, go by the middle door lines first. Gonna rotate it on the y-axis. Use our click drag as a reference point to make sure the door lines in these corners line up with each other. Go like that. And I got that pretty much spot on first try. Got the back doors pretty close. Y rotation done. And we can go like, what's rotation? I keep reading my rotations. Anyway, do the same this side. Usually when you make your own model and the model 3D scan keeps something consistent, is usually keep the bottom door line straight. It's a little bit off. Can increase our gizmo here, give it a little more fidelity. In Maya, it's plus and minus. The bigger it is, the more fidelity you got. It's a little bit off. Closer. And a little bit more. Keep that straight. What you can also do is create a box and get a brain freeze here while I create a box here. So what we're going to use this box for is create a reference point on both sides. We use the box as a reference point for the bottom of the door line. You can check the other side. Obviously, rotation's quite a bit off, so while keeping on that side, while rotating it, keep an eye on both sides to see how both sides are lining up. Bottom of the door line, and we're pretty much there already. So you can go very in depth on how accurate you want. Most of the time, it's blocking things out, that'll be fine. But if you want to get like movie quality amounts of detail, you probably spend a little bit more time aligning the object. Another way, check if your model's line is checking the alignment of the emblems, which is also a good way to find the center of your car. So this edge is lined up within the middle. Go line it up. Torus is a little bit off. Raise it up a little bit more so it clips that side. And we can see it's not quite centered, so I can just move it around. So that's centered. But you do notice one thing, that the rear end is centered, even though we've already centered the doors. There's always going to be a little bit amount of wiggle room because cars are not exactly perfect. Their body panels won't be exactly mirrored over side to side. It's a give or take situation where you want some things mostly aligned and some things a little bit off. You can dive a little bit too deep into these things. But yeah, it's going to rotate a little bit. square it up, so that's a little bit off, a little bit. And then that's a little bit off still. Should be good for the most part. So now that we change rotation, our door alignment will be a little bit off. But yeah, you can see it's still pretty close. As for scaling and reference points, I'm going to look at my current model here. With most cars, you will have access to the dimensions of the vehicle, like length, width, height, and especially wheelbase. To cross-reference your model to scale it up to a proper size. Okay, so here I have length and width. Just quickly check that. Everything's pretty much within bounds. All the way up to the front end and all the way to the rear end. Although I would not count that tail hitch cover in the whole calculation. So now we can see the bumper. It's right on the edge. Fenders all lined up, squared up. There you go. I'm just gonna hide that. You can see here's my current progress on my model. Everything's just sitting on top of the scan model. Fairly accurate now. Before, had some inaccuracies with front fenders, front grille and nose, and especially on the tailgate. Because you can only trust orthographic views when you're modeling cars. Like in this case of this 4Runner, you would assume these doors are perfectly straight. But if you actually line them up, they're actually a little bit smaller to the center than the front doors are. As you can see, the door trim here, if I draw a straight edge, it's about 1 inch smaller, pointing inwards toward the car. So this is a basic overview of 3D scanning your model. As you can see, it's a bit more accurate because of it, as traditional modeling from orthographic views or from blueprints can only get you so far. There's always some subtle little differences that you won't ever see in a blueprint or an orthographic view. With 3D scan, you know exactly where body panels are going to be and where they are. It'll help make your model that's just a little bit more accurate and more believable, especially if you're modeling for TV and film. And that's it for this video. I hope you learned something. And in a future video, I might go over how to do a 3D scan using videos. If that's something you like to see, please comment below, and see you in the next video.